Okay, in this video we are going to talk about how you can solve polynomial inequalities, which is a pretty common thing to do. So polynomial inequalities, they look sort of like this example here, where we've got 3x squared minus 5x minus 2, and then instead of saying equals 0, we're going to say it's greater than or equal to 0. So there's a couple of steps that you got to follow, and I'm going to write them out on the side as I go through the process. So the first one is kind of done for us, but it's everything has to be on one side. So you want this thing to be related to 0 somehow. So either it's greater than 0, less than 0, greater than or equal, less than or equal to, whatever, but it's got to be to 0. So that was already done for us. The next thing that you want to do is you want to make sure that everything is factored as much as you can. So we got to factor as much as we can. So this is a quadratic that I think we can factor. So I'm going to go with 3x and x. And then I need some combination of 2 and negative 1 or negative 2 and 1. So I'm going to go with plus 1 and minus 2. And if you quickly check that, you would get 3x squared minus 6x plus x and then minus 2. So that definitely works. And then the whole thing is still greater than or equal to 0. The next thing we want to do, we want to find the 0 for each of the factors that we just found. So we're going to do that by kind of just by inspection, right? So if 3x plus 1 is equal to 0, then that means that x would have to be negative 1/3. And then if x minus 2 is equal to 0, then x is going to be equal to 2. Okay, so we've got the zeros. The next thing we want to do is create something called a sign chart, which looks exactly like a number line and really serves the exact same purpose. Only the zeros go on it, though. People tend to put too many things on their sign charts. So the only things I'm going to put on this are negative 1/3 and 2. So we've got a sign chart. So negative 1/3 goes on it, 2 goes on it. And now we want to figure out, should we include negative 1/3? Should we not include negative 1/3? What's going on? So if you look at the sign in the inequality, it's greater than or equal to, which means that negative 1/3 definitely works because negative 1/3 makes this thing be 0, and 2 also works because 2 makes it 0. So we want to include those at the end, so we're going to put solid dots. So now we are going to test our regions. So we're going to use really extreme values whenever possible. So, and that usually happens on the leftmost region and the rightmost region that you can use very extreme values. So in this case, I'm going to write down my test values. You don't always do that. In fact, I'm showing a lot more work here than I often do. But this is good work, and I should show this kind of work. So I'm going to test negative 100 in this region because it is less than negative 1/3. When I say it in my head, I usually test negative 1 billion, but I didn't want to write that. So if I test that, so I'm going to go up to the factored form. I'm going to get rid of these lines. So first I'm going to test negative 100 in 3x plus 1. I don't actually care what value I get there. I just care if it's positive or negative. So 3 times negative 100 plus 1 is definitely negative. And so I'm just going to put a little negative sign there. And now I'm going to test x minus 2. So if I plug negative 100 in there, I also definitely get a negative. And remember, I don't care what the value is. I just care if it's positive or negative, because now I just have to think, if I multiply a negative times a negative, it gives me a positive. So if I had picked any number in the region where x is less than negative 1/3, I would have gotten a positive, which is kind of how this whole thing is based. We use that property. Alright, so we have another region. So I'm going to test 0 because it's a convenient number. You should always test 0 if you can. So I'm going to erase these lines. I'm going to take 0 and plug it into 3x plus 1, which gives me a positive. I'm going to take 0 and plug it into x minus 2, which gives me a negative. And a positive times a negative will always give me a negative. So on that part of my sign chart, I put negatives. And we got to test one more region. So I'm going to test positive 100, but again, in my head, I usually test a billion or a trillion. So let's erase these. We're going to take 100 and plug it into 3x plus 1, definitely a positive. Take 100 and plug it into x minus 2, definitely a positive. And a positive times a positive, we know is a positive. So we're basically done at this point. The last thing we need to do is we need to kind of state the solution. So we were looking for where this the product on the left-hand side is greater than or equal to 0. So looking at our sign chart, we can see where the product is greater than or equal to 0. and that's going to be when x is less than or equal to negative 1/3, or, so it's really important to use or there and not the word and, because and means that both things would be true, and it's not possible to find a number that satisfies both of the things we're going to write. So I'm saying or x is greater than or equal to 2. Okay, so that's one example where I showed a lot of work and kind of really went through the steps. I'm going to do another example where I show less work. So say we have this. So it's the quantity 2x minus 1 squared times the quantity x plus 3 cubed times the quantity x minus 5, and then less than 0 is what we're trying to solve for. So I need to find the zeros, so I'm going to go through and do that. So I get 1/2 from here, I get negative 3 from here, and I get 5 from there. Okay, now I need to make my sign chart. It's really important, I didn't mention it last time, it's really important that you put these numbers in order on your sign chart, otherwise things will definitely be screwed up. So I've put them on in order. Now I got to test things. So I'm going to test negative 100, and remember, I'm just looking positive or negative. So if I plug in here, definitely positive because I'm squaring at the end. It doesn't matter what the number is, if it was positive or negative. When you square it, it becomes positive. So positive. When I plug it in here, it's a negative number, and then I cube it, that stays negative. Then when I plug it in here, it's just a negative. So I have a positive times a negative times a negative. Two negatives make a positive, so this is positive overall. Now I'm going to test 0, so let's get rid of these. And if I plug 0 in here, again I'm squaring, so it becomes positive. Here it's 3, so it's a positive, and then I cube it, stays positive. Here it's negative, and it's just negative. So positive, positive, negative, you multiply those, you definitely get a negative. Let's test, 3, I guess. So get rid of these. If I plug 3 in here, I'm going to square the result, so positive. If I plug it in here, it's a positive, and then cube it, so positive. If I plug it in here, I get a negative. So positive, positive, negative is negative. And we're done with that. And so then we'll test 100. So if I plug 100 in here, I'm going to square it, so positive. If I plug it into the other two, actually, I'm just going to get positives both times. So 3 positives, definitely positive. If I look at the inequality that I was given, it's less than, it's not or equal to, which means I cannot include any of the zeros in my solution. So I'm ready to write the solution because I'm looking for where less than 0 is what we were looking for. So that's going to be between negative 3, so negative 3 is less than x is less than 1/2, and then or again, because no number satisfies both of them, 1/2 is less than x is less than 5. And that's it, that's my whole solution. So that's how you can solve polynomial inequalities, by making a sign chart and just testing regions. I hope you found this helpful, and good luck.